Today, first discussion is about the range-based programs. Range-based programs. From the very basic program we are going to discuss. First one is check one number n is even or not. Okay, I'm just so making easy the way of writing range-based programs and all. I'm taking one n value. See, look at this n. So whatever the value. Logic is if it is an even number, I'm printing. That's it. If the number is even number, I'm printing that. I'm printing. Percentage D is even. Is nothing but n is even. N is even. This is the one. See, when you run the code, is looking for n value. Suppose see, consider if I'm giving 4, 4 is even now. Is printing 4 is even. 4 is even. This is checking one number is even. This is checking one number is even. Look at this. Is a 1. One number is even. Now the same code. Look at this. This is n value. N value now is not a single number. See, we are just putting in for loop. For n is equal to 1, n less than or equals to 20 is a n plus plus. First single number checking, then everything we are just put it in the loop. Now here, display events in given range. Now observe the code. First, what is n value? 1. It will come inside checking 1 is even or not. If it is even, it will print. Next, n plus plus. N value become 2. If 2 is even, it will print. Next, n value become 3. If 3 is even, it will print. No, it's not even. See here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Every program I will explain in this format only. Every program. First one, checking one number is even or not. Second one, within the range, how can you print even numbers? Okay. Please write side by side. Now, every program we are writing in the same way. Look at this. Next one is, we already discussed print multiplication table for n. Whatever the number they have given, for that multiplication table we are printing. What is the number? Later we decide. Later. And we already know. For loop we have to repeat how many times? 10 times. I equals to 1. I less than or equals to 10. I plus plus. Inside percentage D is multiplied with percentage D is equals to percentage D. Sir, what to print here? Table number, I value, table number into I. This logic we already completed. That's why I'm not explaining. Whatever the table you given, suppose the table is a 13. 13th table it will print. If you are giving that 17, that 17th table it will give. It is for printing. See, for the given number, we are printing the table. 10 times we have to print. So 10 times we are writing. This is printing the multiplication table. multiplication table for the given number. This is the first one. Okay. Now, sir, I want to print in the given range. In the given range. Very small changes I am doing. See, look at this. Here it is. Here it is. Everything you need to put inside the loop. Just n comma I. Look at this. This is for printing one table. This one you just write in the loop. Don't use ijk, n. Sir, why is n always? Because inside logic we are writing using n already. This is for printing the table of n. Previously, I'm taking n value single value, but not n equal to 5, n less than or equals to suppose 10, n plus plus, n plus plus. Now observe. First, what is n value? 5. So it will come inside. Loop repeats 10 times. N value 5, na? Fifth table will print. Loop completes. Then it will go to outer loop. N value becomes 6. Sixth table will print. Next n value becomes 7. Seventh table will print up to 8, 9, 10. When n value 11, condition fail. Internal logic already you should know. We know already, but you should know because already discussions completed. Today concept is only just adding outer loop as a range based programs learning. See, first one, fifth table, next sixth table, next seventh table, next eighth table, next ninth table, next 10th table. Printing the tables, in the given range. In the given range. First one is printing single table. Second one is what? Printing the table in the given range. Please write side by side. Now, finding the factorial for one number. Already we know the logic. So first, I am writing the logic to find the factorial for one number. Find factorial of n. Taking the n value, whatever it is, we don't know. But to find the factorial, fact we are taking and I we are taking. Loop we are repeating from I equals to 1 or 2, your wish. Right? Here it is 1, I less than or equals to n, I plus plus, finding that fact equal to fact into I. Using the for loop, repeating the for loop from 1 to itself. If it is a 5, we need to do 1 into 2 into 3 into 4 into 5. So it's a 5 factorial. So every time we are multiplying I value with a fact. Outside we are just printing that factorial of particular number is that fact. Nothing but n comma fact we are giving. N comma fact we are giving. Suppose if I am giving n value, consider 5. Just consider. Run it. Factorial of 5 is 120. Is 120. Or just a colon or equal to anything you can write. Factorial of a 5 is 120. Okay. It's any number you can give. Any number, but single number. And the same story. Sir, I want to find the factorial in the given range. In the given range, I already told you, all you need to change only loop. See, this is the logic to find the factorial for given number. Just give the tab for loop. For suppose 2 to 8 factorials I am finding, or 7, n equals to 7, n plus plus. Just outside you need to add one for loop properly. Now we are doing that n. Just factorials in given range. Factorials in range. So first, what is n value 2? With the help of this logic, it will find the 2 factorial. Next, n value become 3. It will find out 3 factorial. Next, n value become 4. It will find out 4 factorial. See, look at this. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. 5 factorial is 120. 6 factorial is 720. 7 factorial is a 5040. So everyone thinking that range-based programs are very difficult. No. If you know the basic programs, all you need to add outside loop only. That's all. If you know that internal logic, how to find out the factorial for one number, all you need to add outer loop only to specify the range. That's all. Okay, please do both side by side, right? Next one, come to the prime number. Prime number and perfect number we discussed now. Now the same. Here. First checking that single number is a prime number or not. Prime or not. So same story. We are taking the number, any number they can give. Any number they can give. As we are finding that count, because you need to find the factors. How many factors it has. For that loop we are repeating, starting from 1 to itself. 1 to itself. If you find out the number is divisible by I, just counting the factor. I'm just printing if count equals to 2, count equal to 2, just percentage D is prime. What is that percentage D? That n. Not prime, I'm not printing. Just if it is a prime, I'm printing. Suppose if I'm giving 7, it will give the output is a 7 is a prime. Sir, suppose if I give 6, 6 is not prime now. I'm not printing anything in the output. Why? Because in the next example, we are writing only prime numbers. Else block is not required. Single number, sir, I want to check this one also. For single number is okay. Percentage D is not prime. Is a not prime. Now it will give the output is a not prime. This is for single number. This is for single number. Okay. But now in the range, whenever you are printing, in the range, sir, I want to print prime numbers. I want to print prime numbers from primes in range. What we have to do, we already discussed. Everything you need to place inside the loop for n equal to, suppose 1, n equal to 1, up to 30, n equal to 30, n plus plus. Outer loop is always you need to write with n. So most of the students will confidently write the outer loop whenever you are writing the range-based programs. In exams, you will fail. Here, so whenever you are practicing on that day, it seems to be very easy. So first you need to write the code for checking one number is a prime number or not. If you can able to write one number is a prime number or not, easily you can add outer loop. Please don't try to write outer loop first and then start writing the logic. You will get confused. Okay. So remember that. Now, n value from 1 to 30. But see here, else block also we are writing now. So when you run the code, what will happen? 1 is not prime. Not primes also printing. Sir, I don't need not primes. I need only primes. So remove the else block. Now if you run that, 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. These are the prime numbers. These are the prime numbers from the range 1 to 30. From the range 1 to 30, these are the prime numbers. Please do. Checking one number is perfect number. Checking one number is perfect or not. We already discussed perfect number means. Perfect number means. First taking that n value. So whatever. Finding the sum of factors. Loop we are repeating from 1 to. No need to check with itself now. Less than or equals to n minus 1 or less than n. Both are same. I plus plus. If you find out the factor, if n mod I equals to 0, got it? If you find the factor, you are adding that factor to the sum. And outside we are checking if the given number and the sum what we found, if both are equal, we can say that n is perfect. N is perfect. Nothing but given number is perfect. Given number is perfect. Printf, n is not perfect. N is not perfect. Suppose if n value is a 6, of course 6 is a perfect number now. Output is a 6 is perfect is printing. 6 is perfect is printing. Suppose if I'm giving 7, 7 is not perfect, it's a prime number. 7 is not perfect is printing. This is for what? Checking one number is a prime number or not. Checking one number is a perfect number or not. One number is perfect number or not. Now in the same way, in the given range, I want to find out. In the given range, perfect numbers in range. In range, same story. Just everything you need to put inside the for loop. Inside the for loop. N value starting from 1 I told up to 10,000 n plus plus. 10,000 times we are repeating the loop. I don't need else. Only perfect numbers I want to print. So why this is an important question in interview? See, look at this. From 1 to 10,000, only 4 perfect numbers are there. From 1 to 10, 6 is a perfect. From 1 to 100, only 2, 6 and 28. From 1 to 1000, only 3, 6, 28, 496. From 1 to 4, 8128. These are. Okay. So within the range perfect numbers. This one. So these are all called range based programs. Okay. Please complete these and quickly go through that all the range based programs. Then we will start learning pattern programs. First, a little theory. Okay. What is that pattern? Pattern means printing the data in two-dimensional format. In two-dimensional format, rows and columns. Rows and columns. See here, I want to write a 5 stars like this. In each row, 5 stars we are writing. In each row, 5 stars we are writing. 2 loops required. One loop, outer loop is representing number of rows. I equals to 2, I equals to 3, I equals to 4, I equals to 5. Now, j equals to 1, j equals to 1, 2, 3, 4, 5. 2 loops required. Here the point is outer loop represents number of rows. Outer loop represents rows and inner loop represents columns. Inner loop represents columns. This is I and J representation. I and J. Okay. Please write quickly. Okay. Now, see here, all the programs based on this logic only. That's why I'm writing total I equals to 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. Total 9 rows I am taking and J 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns I am taking. 9 columns. Here, here. See, first one, 2 loops I am repeating. For 2 loops, 2 variables required na, I and J. For I equals to 1, I less than or equals to 9, I plus plus. This is outer loop. For j equals to 1, j equals to 1, j less than or equals to 9, j plus plus, j plus plus. Okay. Here it is. Now, if you are printing star, see just a star. See what will happen first. Let me show. Because the skeleton is important. When I value 1, Inner loop repeats 9 times. 9 stars will print. Next I value become 2. So 9 stars. Next I value become 3. 9 stars. Total 9 into 9, 81 stars will print, but side by side will print. Look at this. Got it? Got it? 9 by 9. Here, after printing 9 stars, nothing but one row printing is over. Then you need to send the control to the next line, /n. Then 9 stars, /n. Get the output. 9 stars /n. 9 stars /n. Exactly with the square format if you want to see. Just one space, extra space you give. Then look at this, exactly 9 by 9. Exactly 9 by 9. Only point is what? Skeleton is very, very important. Skeleton. When I value 1, using J, you are printing 9 stars. After that, this line is executing. It will send the control to the next line. This one. Please do this, everyone. Okay, now? Now see, look at this. I want to print only, look at this. Only in the 5th row, I want to print stars. 5th row. Rows means I, that we already discussed. Columns means what? J. 5th row and 5th column, I want to print. 5th row and 5th column, I want to print. See, when you are printing star, look at this now conditions. If I equals to 5, then print star. Sir, in remaining places, print space. Don't miss this. Very, very important. Space. See, one space for star. Okay. But here's our extra space we are taking. Na? Why extra space means what? Just for a proper arrangement like with the spaces. So here two spaces you have to give, not a single space. If you remove the space here, you remove the space here, no problem. If you give extra space here, you please give extra space along with this space. Now, if you see the output, see, oh, just a semicolon is missing. If you see the output, only in the fifth row starts printing. No, sir, in fifth column also, either fifth row or fifth column, j equals to 5. Then if you run, look at this plus is a fifth row and is a fifth column. Printing in a fifth row and as well as in fifth column. Please do. This is I equals to 5, fifth row. And this is j equals to 5, fifth column. Okay, now? Now, only just if else. Hereafter, we are writing only conditions. Remaining everything is the same. Sir, I just want to display this box. What is this box? See, I value 1, this line. I value 9, this line. J value 1, this line. J value 9, this line. Total 4. Here it is. First, I value 1. Only first line will print. Next, I value 9. Either first line or ninth line. See, ninth line is printing. Next one is a J. J equals to 1. J equals to 9. J equal to 9. Look at this box is printing. Remaining everything spaces printing. Spaces. Okay. Please write. Just conditions you can write. Don't write the complete code every time. Only just condition and then how it is printing enough. So look at this now is important one. Here it is. I want to display this line. I want to display this line. So here one star at I value 1, j value 1 at intersection point, one star we need to print. Next I value 2, j value 2 at intersection point, one star we need to print. Next one I value 3, j value 3 star. Next I value 4, j value 4 star. At intersection points, we are printing that stars. At intersection points, nothing but when I value and j value both are equal. When I and j both are equal, if I and j both are equal, then this line will print. Now look at this. This is important. I want to print this one slash back. Now observe this. When I value 1, j value 9 star. Got it? Here star. When I value 2, j value 8 star. When I value 3, j value 7 star. J value 7. See, according to this, observe this. I value 1, j value 9. I value 2, j value 8. I value 3, j value 7. If you observe this, 1 plus 9 is a 10. 2 plus 8 is a 10. 3 plus 7 is a 10. According to this, if I plus j equal to 10, then printing this one. This slash is this one. This slash is this one. Please write the logics first. Then I'll show you that output. Okay. Now let me show you the same thing as an example. Look at this. First, I'm just writing I and j equal. Look at this slash. Now this slash we are giving, or I plus j equals to 10. When you add both, it will display this one. Sir, I want to print this line. That is I equal to j, na? Sorry, I equals to 1. I equal to 1 means on top it is printing this one. Sir, last one also I want to write. Last one also. So that is what I equals to 9. I equal to 9 like this. Okay. Just write the condition and print. Only this is enough. Just write the condition and output will be displayed like this.